In the previous topic, you were introduced to the different methods adopted to mine underground deposits. While the basic elements are common to most underground mining operations, there are many variations on the theme. In the next three topics, we will see how these methods can be adapted to mining deposits in different geological situations. Let's start by looking at stope mining in flat deposits. In a previous topic, we were introduced to stratiform and stratabound deposits, which are common for minerals such as coal and iron ore. Where these occur as flat deposits, that is, sloping at less than around 20 degrees, these lend themselves to a particular style of stope mining. What is common to these is that the mining progresses from one part of the deposit to another, mostly within the same plane. What is different is the size and the shape of the pillars used to support the roof and the methods used to form them. Stope mining in flat deposits are distinguished on the basis of the style of the stope, being variously described as rooms, stalls, or boards, and the way in which these are created and arranged. Common classifications include room and pillar, board and pillar, and pillar and stall. The most common arrangement for stope mining in flat deposits is the room and pillar arrangement, where the roof is supported by square or rectangular pillars on a more or less rectangular pattern. The profitability of a room and pillar mine depends on optimisation of the size and spacing of the pillars, so that the greatest proportion of coal can be removed without compromising the stability of the pillars. The mechanics you were introduced to in Module 2 is used by the mining engineer as a basis for determining this arrangement, which depends on the strength of the pillar rock, the height of the pillars, and the spanning ability of the roof. Since stopes are temporary structures, they only need to remain stable for as long as the miners are working within them. This means that the size of pillars is chosen so that they're only just large enough to hold up the load of the roof. Therefore, the chance of a pillar failing is relatively high. If a pillar fails, the load it carries is redistributed to its neighbours, and this increases the chance that they too could fail. If a pillar fails, there is the chance that a chain reaction of pillar failures could be set in place, which could eventually cause the entire mine to collapse. To safeguard against this, mining engineers usually divide the mine into a number of extraction areas, separated by larger continuous pillars, called barrier pillars, which prevent the collapse in one area spreading to another. Rooms are extended and pillars are formed as the mining progresses to its furthest extent, and it is important that these pillars remain stable until the mine reaches its furthest extent. However, as lots of valuable material is left behind in the pillars, and as the stability of pillars is no longer anywhere near as important once the mining has reached its fullest extent, it is common that a second phase of mining takes place as the mining operations retreat from their furthest extent back to the access point. This is done by robbing the pillars, and it can involve shaving slabs from their outer faces or splitting them by cutting through them. The process usually involves the use of temporary support, and at the end of the process it is expected that the roof will collapse. Retreat mining can be dangerous, however, if the roof refuses to collapse progressively or if the roof collapses suddenly with little warning. One way of increasing the recovery in room and pillar operations is to remove the pillars and replace them with artificial supports. These are typically referred to as stalls or props, and timber is commonly used for the purpose. In flat deposits, it is usually possible to employ stalls in isolation between the roof and the floor. In more steeply inclined workings, it may be necessary to use more elaborate arrangements, employing vertical and horizontally arranged stalls to achieve support stability. The extent to which stalls can be used to replace pillars depends upon the amount of vertical stress to be carried, the strength of the stall, and the height of the rooms. It is uncommon to use stall support for rooms higher than 4 metres. In the next topic, we'll take a look at how stoping is carried out in deposits that aren't flat.